Hello everyone, welcome to 3710 class. This is chapter 6. In this chapter we're going to look at the counting skills. The objective for this chapter includes the following. We're going to look at the basics of counting, pigeonhole principle. We're going to introduce concepts including permutations and combinations. And then we're going to introduce what are binomial coefficients and identities. And then we're going to look at the generalized permutations and combinations. We're going to introduce some examples so that you can understand these concepts. First of all, let's look at the basics of countings. There are many rules to assist the counting. There are the product rule, sum rule, subtraction rule, division rule. So these rules will be very useful when you're trying to count different methods, how many ways for each method. And finally, there is a graph method, which is the tree diagrams. First of all, let's look at what is the product rule. Product rule is when you have a task. Let's say there's a task A and there's a task B. So these two tasks are in sequence. That means you can only finish A first, then you finish B secondly. And then these are actually in a sequence. For example, there are n1 ways for task A and there are n2 ways of task B. So the total will be n1 times n2. This is a product rule. Let's take one example. How many bit strings of length 7 are there? To look at this question, you can think of the bit strings as a sequence of positions. In this example, there are 7 of them. Okay, so and each one of them is one by one, so they're in a sequence. And let's look at the first bit. You can either start from the left to the right or from the right to the left. So let's see, the first bit, there are two choices. Okay, so it can be either 0 or 1. Second is either 0 or 1, and also goes on. Therefore, you break this task of length 7 bit string into 7 small tasks, and each task has two choices. Therefore, the total should be 2 times 2 together. There are 7 of them. So therefore, finally, the total should be 2 to the 7th power, and it should be 128. Another example, also using the product rule. How many different license plates can be made if each plate contains a sequence of 3 uppercase English letters followed by 3 digits? So in here you can see the task can be thinking of that you can take it as 6 positions, and the first position, 3 positions are the uppercase English letters. Each one are 26, and then the last 3 positions are digits. So each one is a 10. So together, just time this number together, it should be the final answer. Okay, so the final answer should be this product. Next, counting functions. How many functions are there from a set with m elements to the set with n elements? Now, we know that function is, you start from a set A to a set B, and this is function. And for each element in A, they're mapped to each element in B. There are m elements here, there are n elements here. So the function is the A definition for a function is for each one of element in A, it can only be mapped to one element in B. So we have to make sure that your count follows the definition of the function. So the answer is we try to look at each element in A, and we found that each element in A, each one of them has n choices to be mapped to the B. Because for each element you can only have one choice of element in B, so that's the definition for function. So each one of them should have n different choices. So finally, that's n times n together. There are m of them together. So that's n to the m's power. Next question is how many one-to-one functions are there from a set of m elements to the one set with n elements. So therefore, go back to here. Again, you can see that we can consider still also from A to B. But if the first element has taken a choice, which have n choices, so next one should have n minus 1 choice, and next one should be less and less. So then we can time the number together. So the answer is the first element has n choices, next n minus 1, n minus 2, until n minus m plus 1. And we assume that n plus 1 is greater than m. N is greater than m. Okay. Next question is very interesting. We have introduced the concept called power set, right? So let's look at what will be the cardinality of a power set. Use the product rule to show that the number of different subsets of a finite set S is 2 to the power of the cardinality of S. So this function, we can think of a set and it has element, let's say is from A1 to AN. Okay, and we can consider when we are constructing a subset, we can look at each one of the elements. Okay, so here n is equal to capital S cardinality. And then for each one of the elements, it can be included in a subset, yes or no. And the second element also can be included or not included. Last element can be included or not included. Okay, so if you look at each one of the elements one by one in a sequence, you get all the subsets. And we can also consider if a element is included in the subset, it can be considered as 1, otherwise 0. So 1, 0, 1, 0 on every one of the elements. And therefore, this element in a subset can be any subset of S, capital S, can be translated into a bit string. So for position 1 to position n. So if it is 1 on the position, then it is included, the element is included, otherwise it is not included. So therefore, there is a one-to-one correspondence between the set of bit string and the subsets of each one of subset of capital S. So therefore, we can use this method to find the one-to-one correspondence between the subset of S, capital S, and the bit string of length, the cardinality of capital S. And then if the ith element in the bit string is ith element in the set is included in the subset, then the bit string has 1 in ith position. Otherwise, it's 0. And we use the counting skill to calculate how many bit string of the length n, and we can easily find out each position has 2 choices. So this is 2, 2, and 2. And there are n of 2s together. So that's 2 to the nth power. And n equals to the cardinality of capital S. So therefore, the final answer is 2 to the cardinality, the capital S cardinality. And then this will tell us that the size of any set's power sets. And we can use the product rules in the term of sets. So if A1, A2, AM are finite sets, and the elements inside the Cartesian product of these sets is actually can be calculated using the product of the numbers of elements of each set, just using the counting rules. Okay, so therefore the continuity of the Cartesian product of A1 to AN is equal to the continuity of A1 times continuity of A2 times continuity of AN. Okay, so this is actually directly from the definition of the Cartesian product. So the second rule is called the sum rule. Sum rule is that you have a task A and you have a task B. However, they're not in a sequence, so they are side by side. So you can either go to complete task, you can either go with task A or task B. And there are N1 ways to do task A and 2 ways to do task B. So that together there are N1 plus N2 ways. Okay, so this is actually the sum rule. So let's say for the following example, the department must choose either a student or a faculty member as a representative. So please pay attention, this is an or here. So therefore the two situations are side by side. And as the representative for the university committee, so how many choices are there for this representative if there are 37 members of the faculty and 83 students? And we also know that no one is both a faculty and a student. So therefore you know that this is using the sum rule. Basically you can either choose a faculty member which you have 37 choices, and another you can choose a student which is 83 choices. So together the final choice should be 37 plus 83, which is 120 in total. In terms of the set, to look at the sum rule, you can consider that when we have a set A and set B, the union together, and then the two sets are disjoint. So the total, the unions of two sets, the continuity is equal to the continuity of A plus the continuity of B, because they are disjoint. And for a larger sequence of sets, let's say A1 to AM, and any pair of these sets are disjoint, then the union of these sets together is basically equals to the sum of the continuity of A1, A2, and AM together, because each two of them, any two of them are disjoint. And then if there are common parts between any one of the two sets, then we're going to use a different rule, which we're going to introduce that later. Let's look at this example. Suppose there is a statement labels and in a programming language, and the statement labels can be either a single letter or a letter followed by a digit. So there are two ways. Okay, so it can be either a single letter or it can be a letter followed by a digit. So we assume these are uppercase letters only. The question is find the number of all possible labels. So you can consider this is your task A, just using one single letter, or you can use the task B, which is a letter followed by a digit. For task A, you know there are 26 choices, and task B, you can use the product rule. So task A is equal to 26 because this is just a letter, and task B you can think of as first as their letter, there are 26, and then following the product rule, the second position is a digit, so there are 10, so it's 26 times 10. So in total, using the sum rule, which is equals to 286. Next question, let's look at this example. Sometimes you can combine the sum rule and product rule together for more complicated problems. For example, each user on the computer system has a password, and which is 6 to 8 characters long. And for each, where each character is an uppercase letter or a digit, and each password must contain at least one digit, Okay. So how many possible passwords are there? So for this question, you can think of that you decompose the task, the passwords total can be equals to how many 6 passwords, how many 6 character passwords are there. So P6, and then P7, so how many 7 character passwords, and then plus P8, how many 8 character passwords. And then you calculate the number for each one of the P6, P7, P8, and you can calculate the total answer. And also be careful that we require that each password must contain at least one digit, So for this one, you can think of this way, the opposite way. You can consider to calculate a number. So that's it. The how many password in total in uppercase, lowercase, and uppercase letter, and also digit. It does not matter if there is at least one digit or not. And then minus the password, there is no digit. The number of password, no digit. Okay, and then you can calculate the number for each P6, P7, and P8. So let's look at the answer. So basically, you can consider the P is equal to the sum of P6, P7, and P8. And let's look at one of them, each one of them. And we can find the number of passwords for the specific length by look at all the cases and subtract the number composed only of letters. Okay, so that means there's no digit. And then you can get each one of the length passwords, number of the passwords. For example, for P6, so each position can be either uppercase letter or digit. So there you can use product rule first to get all the total possible passwords. So each position is 36. So there are 6 characters. So that's 36 to the 6. And also minus the password only has the letters. Okay, so uppercase letters. And this is 26 and to the 6. So using the first number minus the second, so that will be the password has at least one digit, because this is the total possible password. This is all the passwords with only letters. So the total minus the second is password contains at least one digit. So this is, you get P6. Continually, you can also get P7 and P8. Finally, add them together. This is the total. If you encounter any questions like this in your assignment, which have this large number, and you don't have a calculator, you can just put these formulas inside your answer, so that I can see how you did this answer. I will still give you points. Next rule is a subtraction rule. As you can see that if you look at the task T1, TA, TB, they're side by side. There is N1 way to TA and N2 way to TB. If they're disjoint, you can use sum rule. Okay, but if there is any common part, then you're gonna need to use the subtraction rule. So the total task will be N1 plus N2 and minus the common of the two different ways. So this will be, this is called the subtraction rule. And using the set language, the cardinality of the set A union B is equal to the cardinality of A plus cardinality of B and minus their common parts cardinality. So this is also known as the principle of the inclusion exclusion rule. Let's look at the following example. How many bit string of length 8 either start with 1 bit or end with bits 0, 0? So for this question, you can think of that using the subtraction rule. So let's look at the first situation is start with 1 bit. Second is end with 2 bits. So you can calculate how many how many different possible cases for each one of them. But also remember, there are also strings start with a 1 bit and also end with 0, 0. So you need to subtract this number also. So this will be the solution. Okay, so you can think of that, calculate how many different ways for strings start with 1. So this is your first number. How many ways start with ends with 2, 0, 0? So this is the second number. And also you need to, the 2 method has a common part, which is the here start with 1 and at the same time end with 2 bits 0, 0. So there are these numbers. So the first number plus second number minus third number shall be the answer. Okay, so this will be the answer right here.